breakthrough projects. In this video, we are going to explain about the project that is early detection of lung cancer using predictive modeling, incorporating CTGAN, that is CTGAN features, and tree-based learning. So before getting into the execution, first let us understand what is this project about. Artificial intelligence, or we call it as AI, it has completely changed the way healthcare works. With a huge amount of medical data being collected every day from patient records to the lab results, AI helps doctors make sense of it all quickly and accurately. So, by analyzing these large data sets, AI can identify patterns that might be too subtle or complex for humans to notice. This allows doctors to create treatment plans that are more precise and tailored to each patient needs. Coming to this lung cancer, unfortunately, it is one of the deadliest types of cancer in the world, leading to millions of deaths every year. One of the biggest challenges is that in early stages, it is often doesn't show clear symptoms. So many patients are diagnosed too late. Detecting it early is crucial because it can dramatically increase the chances of survival. AI can help in this early detection by analyzing medical data and predicting who might be at risk, giving doctors a powerful tool to intervene sooner and save lives. Right now, the ways we detect lung cancer have some serious limitations. Many of these, that is, many of the data sets used for analysis, are small, which makes it hard for models to learn patterns accurately. On top of that, these data sets often have class imbalances. For example, far more cases of cancer than the healthy samples, which can cause models to be biased and less reliable. Because of these issues, the predictions made by current methods aren't always as accurate as we would like. So, this is why there is a big need for automated and trustworthy tools that can predict a patient's risk of lung cancer more reliably. If we can develop such systems, it would allow doctors to detect the earlier, that is, disease earlier, treat it more effectively, and ultimately save more lives. Better predictions also mean healthcare professionals can make more informed decisions, leading to improved outcomes for patients. So, here, the system we are proposing is all about detecting lung cancer as early as possible. One of the biggest problems with the lung cancer is that its early symptoms are often very subtle. So it usually gets diagnosed late. Catching it early can make a huge difference in patient survival. And that's exactly what this system aims to do by using advanced AI techniques. So here, we start with a publicly available dataset that contains information about patients, including their age, lifestyle habits, and symptoms. But here the challenge is that the dataset is highly imbalanced, meaning there are far more cases of cancer than healthy examples. To fix this, the system uses CTGAN, that is Conditional Tabular Generative Adversarial Networks, which is a type of AI that can generate synthetic data. So this helps to balance the data set so the model can learn from all the type of, that is, it can learn from all types of patients more effectively, making it reliable tool for predicting lung cancer risk. And before the system can start doing predictions, the data need to be prepared properly. This involves converting information like gender or symptoms into numbers that the computer can understand and remove any errors or the noise and organize the data set so it is ready for training the models. Once the data is ready, the system uses several machine learning models. So it uses models like random forest, which is being the main model because it is very accurate and reliable, and the other models like support vector machine, which is SPM, KNN, which is k nearest neighbor, and decision trees, and also ensemble methods, which are also tested to see how they perform. And to measure how well the models work, we look at metrics like accuracy, precision, recall, and FN score, and the system is further validated using five-fold cross validation to ensure that it is reliable. And to further improve the performance of this project, here we have added some improvements to make the system more accurate and reliable. So first, during data pre-processing, here we have removed outliers to ensure the data set was cleaner and the models could learn better. Then we have applied more advanced data balancing techniques that combine ADA, SYN, and cluster centroids, which help the models learn equally from all the types of patients. With these enhancements, the gradient boosting classifier achieved the best performance among all the models which were tested, making the predictions even more accurate and dependable. Moving on, another extension of the project focuses on making the system more understandable and user friendly. For that, we have incorporated explainable AI techniques like LIME and SHAP, which show exactly how the model makes its predictions. This means doctors and medical professionals can see which factors influence a prediction, making the system transparent and trustworthy. And here we have also developed a front end by using Flash framework. This allows users such as healthcare professionals to securely enter patient information and get predictions. The interface includes authentication to ensure that only authorized users can access the system, keeping patient data safe while making the tool easy to use it practically. Now, moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So, let's understand how we have implemented this project. First, we started importing all the necessary libraries required for data handling, visualization, machine learning, and model evaluation. Then comes exploring the dataset. Here we have used publicly available lung cancer dataset from Kaggle to understand the structure, features, and the targets. Then comes data visualization. Here we visualize the distribution of the target values to see how many patients have lung cancer versus those who don't. We have also plotted a correlation matrix to understand relationship between different features. Then comes pre-processing. So here we will be removing, that is duplicate records are removed to clean the data set, and categorical features like gender or symptoms are converted into numerical values using label encoding to see the models can process them. And then comes data balancing. So here in this step, the data is imbalanced. So we train models on various versions of the data, that is original unbalanced data, smooth. We will be using smooth technique to balance the data, broadline smooth technique, smoothing technique, CTGAN, which is the proposed model, and the extension model that uses ADA, SY, and cluster centroids. So here we will be training models on the unbalanced data and also the balanced data, which are these techniques. Balancing data includes these techniques. Then comes splitting the data into train and test sets. So we will be splitting the data into train and test sets, where train set is used to train the model and test set is used to evaluate the model. Then comes model training. Here, multiple machine learning models are trained and fine-tuned using five-fold cross-validation to ensure the models are reliable and not overfitting. Then comes model evaluation. So the trained models are compared using metrics like accuracy, precision, recall, and FN score to determine which performs best. Then comes results visualization. So we compare graphs and that are generated to visually show how the performance of all the models across the evaluation metrics. So the metrics which are accuracy, precision, recall, and FN score. Here we will be using these metrics to show in the graph. I mean performance of all these metrics, all these models will be shown through graphs. Then the best performing model will be saved for the future use. And then comes explainability. So techniques like LIME and SHAP are applied to show which features influence the predictions, making the model decisions interpretable and trustworthy. Moving on to the front end. So here, a web interface is developed using the Flash framework, which includes registration and login functionality supported by SQLite for secure access. And in the front end, users will be able to provide input feature values that will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us the output. Moving on to algorithms used, these are the algorithms used, which are XGBoost, extra tree classifier, support vector machine, k nearest neighbor, stochastic gradient descent, logistic regression, decision tree, random forest, gradient boosting classifier, naive Bayes. So these are the algorithms used. And to implement this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So these are the source code files. Let us understand each of them. How will they be used in this project? In this folder, we have the dataset. So this is the survey lung cancer dataset that we have used to train the models for predicting the lung cancer, whether the person has lung cancer or not. So here we have multiple attributes. So based on gender, age, smoking, yellow fingers, anxiety, peer pressure, chronic disease, fatigue, allergy, wheezing, alcohol consumption, coughing, shortness in breath, and swallowing difficulty, chest pain. Based on all these parameters, we will be predicting lung cancer. So model will be trained on all these features to predict this lung cancer. Now close this, get back. This is the model folder in which we have algorithm information stored in .hy files, numpy files, and pickle files. They will be loaded into the project code during runtime of the application. This is the static folder in which we have CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. So it contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And in this, we have test cases that we will be using in the front end. This is the app.py file, which contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file, which is the database file used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So copy the path. I have copied it. Now open Anaconda prompt. So it is open. Now give the command cd, give the space, paste the copied path, click on enter. Here you can observe current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while. File is being compiled and here we got the address. So this is the address where application has been hosted. This is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I've copied it. I prefer Chrome, so I will paste it in that. Paste link here. Click on enter. So this is the web page of the project which is displayed in the browser and this is developed using Flask framework. So we need to get registered first. So you can click on register or click on get started. So let's click on get started. And you need to create an account. So you need to enter all these details. I have already created, so I'll directly log in. Give your username and the password. And now click on login. If you have entered wrong credentials, let me enter again. Now click on login. So we have logged in successfully and redirected to prediction page of the project. Here you can see different parameters, right? So these are the parameters need to be given for predicting whether the person has lung cancer or not. So the first one is allergy. That is whether the patient has any allergies that could affect the lung health. Then we have alcohol consumption. That is the frequency or level of the alcohol consumption by the patient. Then here we have swallowing difficulty, whether the patient experiences trouble swallowing. Then we have wheezing. So this wheezing, it is the presence of wheezing or breathing difficulties. Then we have coughing. So it is the frequency or severity of coughing. Then we have peer pressure. So here we have peer pressure. It is the influence from peers that might affect the habits like smoking. Then we have chest pain. So it is whether the patient experiences pain in the chest area. Then we have yellow fingers. It is the indicator of smoking or nicotine exposure. Then we have anxiety. So it is the presence of anxiety or stress affecting the health. Then we have fatigue. It is a level of tiredness or exhaustion experienced by the patient. So this is all about the features. Now let's enter them. For that, let's open the test cases. So open test cases. Open the sample file. Here it is open. Let's start entering them. Let's apply filter to the lung cancer column. So because we will be predicting them, so we will be not giving input as this column. This we will be predicting, so this we will not be giving. So let's apply filter. Let's check with no. So filter for no, and let's start entering them. Here, allergy. So person has no, yes, allergy. I mean person has allergy. And alcohol consumption, yes, he consumes the alcohol. And then swallowing difficulty, he has swallowing difficulty. And wheezing, he has no wheezing. Coughing, he doesn't cough. Pure pressure is also no. Chest pain, also no. Yellow fingers, yes. And anxiety, he has anxiety. No fatigue. Now click on get prediction. So this given input, it will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us a prediction. And here we got the prediction that it is lung cancer not detected. Here we have description that lung cancer risk assessment indicates that lung cancer is not detected based on the provided symptoms and the risk factor. The analysis shows a low probability of the lung cancer. However, it is important to maintain regular health checkups and consult with healthcare professionals for any persistent symptoms. And here we have 50% confidence. And these are the recommendations for the patient because he has no lung cancer. So let's try doing new prediction. So click on new prediction. And let's check with this case where person has no allergy, no alcohol consumption. Sorry, he consumes the alcohol and he has swallowing difficulty and wheezing. Yes, he has wheezing. Coughing. Yes. Pure pressure is also yes. Yellow fingers. So chest pain is yes. Yellow fingers are yes. Anxiety, yes. No fatigue. Select no fatigue. Now click on get prediction. So here also you can see there is no lung cancer detected and this is the model confidence score. Now let's check with the other case. So click on new prediction and let's apply filter to yes. Click on OK and let's check with this case where person has no allergy and alcohol consumption. Yes, he consumes the alcohol. No swallowing difficulty. Wheezing is yes. Coughing is also yes. Pure pressure is also yes. Chest pain type is no, no chest pain. And yellow fingers, he has yellow fingers. Anxiety is yes. Fatigue is no. Now click on get prediction. Here you can observe lung cancer has been detected correctly. So here we can see prediction. The lung cancer risk assessment indicates that lung cancer is detected. Based on the provided symptoms and risk factors, the analysis shows high probability of lung cancer. This is a serious condition that requires immediate medical attention and further diagnostic testing. So here you can see model confidence score and here are the recommendations that it is urgent. So it is telling please consult a doctor and etc. And here it is immediate medical consultation and here we have diagnostic imaging. So consider a schedule for a chest X-ray or CT scan to get disabled view. So basically it is giving recommendations here. Now let's try with the last case. So let's try with this one or else let's try with this one. So allergy is yes, he has allergy and alcohol consumption no. Swallowing difficulty is yes. And then wheezing is no. And then coughing is yes. Pure pressure is no. Chest pain is yes. Yellow fingers, no. Anxiety, it is no. And no fatigue. Now click on get prediction. So here also you can observe lung cancer has been detected. Now let's check with the analytics, that is the graphs. So click on view analytics. So here we have confusion matrix. This is a confusion matrix where here on x-axis we have predicted and on y-axis we have true classes. Close this. And this is the accuracy score where on x-axis we have all the models that we have trained and on y-axis we have accuracy score. Close this. Similarly, we have precision score. This is the precision score. Here we have recall score comparison graph. And here we have FN score. And here we have radar plot. So here we have accuracy, precision, recall, and FN score. Now close this. This is of GBC model, gradient boosting classifier, which achieved highest performance with the extension technique. Now click on logout. So in this project, we have developed a smart system that can help detecting lung cancer early by analyzing the patient information and health patterns. Early detection is crucial because it can save lives and important that is it improves treatment outcomes, and our system not only provides accurate predictions but also helps doctors understand the key factors affecting each patient. With a user-friendly interface, it makes accessing this important information easy and safe, supporting better healthcare decisions and giving patients a better chance at timely treatment. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.